graphing paper.
Here is the homework for section 7.1. This is day 2. Now, this is kind of building on yesterday, but it's a little more challenging because what they want you to do, and I didn't give you any graph paper, so you have to do this freehand. I want you to graph the sine curve, but only the interval 2 pi to 6 pi. So, let's draw an axis, x and y axes. Now this is the way you should do this. So it started at 0 and it went pi over 2, pi, 3 pi over 2, and then 2 pi, right? Wave to the camera when you go by. Troy and Courtney.
You leaving?
No, you just have to work. The mom-to-mom sale. So 2 pi, now you've got 1, 2, 3, 4. That's going to be 4 pi.
That's naturally right.
1, 2, 3, 4, and that's going to be 6 pi. Okay, so, and then you can just go 1. This is going to be 1, and this is going to be negative 1. So the graph normally for sine, it starts here, and it goes up, down, down, and up. We would normally start there and do this. Whoops. But they don't want that. They want you to start here. So the actual answer would be this, 2 pi, and then that, and this, and down 1. So you're going to have, the answer would be this, and then they want another period from 4 pi to 6 pi. Does this make sense?
Yes.
So they're asking you, can you graph like a section that's not, so in other words, it was a bad eraser. You're going to erase this part. That's not part of the answer. That's the answer. Okay? But I like to start off like that. So now this next one is asking you to graph from pi to 3 pi. So this is what I do. I make my graph. And I have 1, 2, 3, 4. That's 2 pi. This is going to be pi. This is pi actually. This is 3 pi over 2. And this is pi over 2. So then they want you to go to 3 pi. So 1, 2, that's 3 pi right here. So how do you go from pi to 3 pi? That's where you're going to start, and that's where you're going to stop. What does the cosine graph look like? It starts high, so it starts here, and it would normally come down, and to pi, and here, and up, here, and here. So from pi, this is what they want you to do. And stop. We don't want this part. That's the graph of the cosine curve from pi to 3 pi. Does that make sense?
Yes. See?
Okay, question number 7. For what values on this interval, negative 2 pi to 2 pi, is the, that's the wrong question, is the y value equal to 1? So look at the notes that we just did. And here was the picture. Here's the sine curve. Where did you get a 1? Where is y equal to 1 for the sine curve? Pi over 2. Where's pi over 2? Right here. It's going to happen here. And it happened here, but that's past 2 pi. So if we write pi over 2, and write plus or minus 2k pi, that's what I want you to do, because that's going to give you all of the answers both ways. And that's good enough. You don't have to worry about anything else. Just leave it like that. Same with this one, number 8. I want to know where are the y values for cosine equaling 0. We did this in the notes. So it's the same question. It'd be pi over 2 plus 2k pi and 3 pi over 2 plus 2k pi. What is the maximum value for the cosine of t? Remember we did the max and the min? What's the highest? It's an easy question, it's 1. What's the minimum? -1. That's easy. We're gonna skip 11 and now look at 12. Number 12 is asking you, what is the y-intercept of the graph of the sine curve? Where does the sine curve start? It goes like this, right? So what is the y-intercept? 0, 0. Does that make sense? Okay, can you tell me where the y-intercept is for the cosine curve? Here's the let's graph the cosine curve. This one. What's the y-intercept?
0,
0, 1. Good job. 0, 1. We're going to skip 14 because it's a tangent problem, but we're going to do 15. 15 says, for what value of t on the interval negative pi to pi is it increasing? So if we graphed negative pi to pi, here's 0. So this thing looks like this. Here's pi over 2, and here's pi. We really don't need the rest of it, but this thing is going to come down and go up. So they want, that's negative pi here to pi. Can you tell me the, and this is negative pi over 2. Can you tell me the interval from here to here where the sine graph is increasing? What would you write?
Negative pi over 2 to pi 2.
Good job. Negative pi over 2 to pi over 2. And for 16, can you tell me, from negative 3 pi to negative pi, is the cosine graph decreasing? Well, it looks like we're going to have to graph something here. So we're going to start at 0, negative 1, negative 2, negative 3. We're going to do 4. Yes?
Hey, Miss Ani, how you doing?
Good, how are you?
Good. Do you know what Mr. Fast is?
I don't. Check Mr. Owensby's room, or
Alright.
Savanovic. I think I saw him there.
I saw him in the streets a lot.
Cool, thank you.
Okay, so does everybody understand this is negative 2 pi here, and this is negative 4 pi? So the cosine graph, it looks like it's normally going this way, right? We've seen it that way. Let's go the other way, because we want to see, this is going to be here, and here, and up here, and here, and here, and here. And actually, they just want, they want 3 pi. So this is negative 3 pi right here. See, the question says from negative 3 pi, that's negative 3 pi. And that is, where's negative pi? 1, 2, there's negative pi. Okay, so can you tell me what the interval is where it's increasing? It'd be negative 3 pi to negative 2 pi. And that's it. Oh, decreasing. I did increasing. No.
So no.
It's supposed to be decreasing.
It's decreasing. So we want, it's decreasing from here, right?
Negative 2 pi to
Negative 2 pi, thank you, to negative pi. Thank you. Okay, now, these ones get a little tricky. I want you to do, we're going to skip around. 22, 26, that's 26, and 28 are like the notes. Can you tell me, looking at the sine curve, now how I know that these are like the notes is because when you see a number like 0 or 1 or -1, those are on the x or y axis. So can you, looking at the sine curve, can you tell me, here's the sine curve, where do you get a 0? Right here and here. So the answer is pi and 2 pi. Okay? So you get a 0 at pi and at 2 pi. Does everyone see that? You get a 0 here, 0 and pi and 2 pi. You could say 0, pi, and 2 pi. So 0, pi, and 2 pi. So 0, pi, now 2 pi is the same as 0. So you're going to do 0 plus or minus 2k pi and pi plus or minus 2k pi. Now if I write 2 pi, it's the same as that point because those are coterminal. Now do the cosine one at 0. Here's the cosine graph. And this is the second time you saw this question. Where do you get a 0 for cosine? At pi over 2 and 3 pi over 2. At pi over 2 and 3 pi over 2, and then plus or minus 2k pi. Now the reason why I'm adding this 2k plus or minus 2k pi, because the directions say find all. Now the last one that's pretty basic is the sine 1. Where did we get a 1 for the sine curve? Where do you see a 1 here?
Pi over 2.
At pi over 2. It occurs again here, but that's past 2 pi. So if we just write for this one, pi over 2 plus or minus 2k pi, we've covered all bases. Okay? All right, now the other ones that we have to do are not on the x and y axis. So this is what you have to do. These get a little crazy. Now I want to talk about this really quick. In each of these quadrants, sine and cosine is positive or negative. Okay, so in quadrant 1, sine, cosine, and tangent are all positive. Why are they all positive? Because when you draw your triangle in quadrant 1, your x value and your y value are both positive. So any ratio you do is going to be positive. In quadrant 2, when you draw your triangle, your x value is negative and your y value is positive. So only the sine is going to be positive. Cosine and tangent are negative fractions in this quadrant. So you got to know this. All seniors take calculus, or all students take calculus. In quadrant 3, the sine and the cosine fractions are going to be negative, but the tangent one's going to be positive because a negative over a negative is a positive. And in quadrant 4, the cosine one is positive, but tangent and sine are both negative. Okay, you got to know that. So these answers are going to happen in 2 quadrants. So this is what you have to do. Here's the first question. Sine of t is root 2 over 2. You always start in quadrant 1, whether it's positive or negative. Now, what does the word sine mean? It means opposite over hypotenuse. Can you tell me what angle am I? What angle am I? I just,
45 degrees.
you're a 45, good job. You're a 45-degree angle, so guess what? That's one of your answers. 45 plus or minus 2k pi. Now, if I took this triangle and made it, what other quadrant is the sine ratio going to be positive in? What other quadrant?
Quadrant 2.
Quadrant 2. So what you're going to do, you're going to take this triangle and you're going to put it in this quadrant right here. But you've got right here, this is going to be root 2 and this is going to be 2. Now this is a, like John said, this is a 45-degree angle right here. But I want this measurement right here. So if this is 45, what's it from here to here? Can you figure that out?
135.
What is it?
135.
Can you give it to me in radians?
3 pi over 4.
Yep, 3 pi over 4. So from here to here is also, so this ratio is going to occur at not only pi over 4, but 3 pi over 4. Okay? Let's try another one. Cosine. Now, it's negative. Ignore the negative for a second. In what two quadrants is the cosine ratio negative?
3 and 4.
It's gonna be in these two right here, right? Those two. So my angle, it has to be in these two quadrants. So it's gotta be between pi over 2 and pi and pi over 2 and pi and 3 pi over 2. Those are my two answers. Because those are the only two quadrants that the cosine ratio is negative. So this is what I do. I ignore this negative for a second. And I draw a triangle in quadrant 1. And I'm going to name this side 1 and this side 2 because it's cosine. What angle am I?
30 degrees.
You're a 30-degree angle. Can you name 30 in radians?
That's pi over 3.
Pi over 6. So you're going to put a 30-degree triangle in quadrant 3. So let's do that. Let's put it in quadrant 3, a 30-degree. So this is pi over 6 right here. But I don't want that answer. I want this answer. So what is it from here to here? It's 5 pi over 6. And then add and subtract 2k pi. And now you're going to put a 30-degree angle in this quadrant. So I want from here to here now. So it's pi plus pi over 6, which is 7 pi over 6. Plus or minus 2k pi. We're going to be doing these problems from now until May. So get used to this, okay? Let's do another one.
I quit.
Seriously, the quicker you pick this up, the better. Okay, the next one. This is giving you, let's ignore this negative for a second, ignore it. You're gonna draw a triangle in quadrant 1. We need it's called a reference angle that you're gonna use. This is root 3 and this is root 2. What angle am I?
60.
A 60-degree, pi over 3. But I need to put a 60-degree angle in quadrant what and what? Which two quadrants give you, is the sine ratio going to be negative in?
3.
3. So I'm going to put a 30, that's a 60. Put a pi over 3 in this quadrant. I want this measurement right here. So what's pi plus pi over 3?
Pi.
4 pi over 3, that's one answer. Plus or minus 2k pi. And I also need to put a 60-degree angle in this quadrant. So what's it from here to here?
7 pi.
What is it?
Just kidding.
5 pi over 3?
3, yeah.
Plus or minus.
7, 8, 14.
Okay? Next one. Positive. We like it when they're positive. So we're going to draw a triangle in quadrant 1. It's a cosine one. So we're going to call this root 3 and this 2. What angle is this?
3 pi over 6.
Pi over 6. What two quadrants is cosine positive in? First and, so that's one answer. Pi over 6 plus or minus 2k pi. And we have a 30-degree angle in quadrant 4. So if you were to draw a 30-degree angle in a pi over 6 angle, what is that angle? From here to here. If you put pi over 6 right here, so I want to measure from here to here.
11 pi over 6.
11 pi over 6. Try cosine of 1/2. So, and thank God it's positive. So we're going to draw a triangle in quadrant 1. We're going to name this 1 and this 2. What angle am I?
30. 60.
30.
Thirty.
30 is 5%.
Yep, pi over 6. So this angle is 30. Okay, because it's positive, that's one of your answers. So pi over 6 plus or minus 2k pi. What other quadrant is sign positive in? Second. So we're gonna put that 60 in this quadrant. We attach it to here. This is I'm sorry, pi over 3, 30 degrees. So what angle is this? And it's gonna have a 6 in the bottom of it. What's the one with the 6 in the bottom in the second quadrant? 5 pi over 6.
How you guys just learned
The unit circle.
that?
Let's do it really fast, because it will help you. It will help you, John.
You should give us a unit circle on our test. for
No, you do
reference.
this. You do this, watch. The more you do this, and I know I've done it several times, watch how fast. This is what you should do, seriously. 0, a half, a whole, 1 1/2, and 2. Remember this? Do the quarters. 1 quarter, this is 2 quarters, 3 quarters, 4 quarters, 5 quarters, 6 quarters, 7 quarters, and 8 quarters. Okay? So 1 quarter, 2 quarter, 3 quarter, 4 quarters, 5 quarters, 6 quarters, 7 quarters, 8 quarters. Now do the 6s. This is a 6th. This is 2
So
6.
pi over 2 is the same thing as 2 pi over 4.
Say it again. 1 6, 2 6, 3 6, then 4 6. Yeah, you can reduce these. 5 6, 6 6, 7 6, 8 6, 9 6, 10 6, 11 6, and 12 6. I do that. That helps me. So when we start to talk about a 30-degree angle in quadrant 2, I know it's 5 pi over 6. If we're talking about a 30-degree angle in quadrant 3, it's 7 pi over 6. If we're talking about a 30-degree angle in quadrant 4, it's 11 pi over 6. And remember that these have other names like pi over 3. Okay? So let's go back to this one. Let's do one more. I think we just have one more of these. 31. So what angle are you? Root 2 over 2. You'll get good at this once you keep doing these. Root 2 over 2. Ignore the negative for a minute. Just name this root 2 and this 2. What angle are you?
45.
That's a 45. Now, unfortunately, that's not the answer because cosine is not negative in quadrant 1. We just need this number so we can stick it in the correct quadrant. So what two quadrants is cosine negative? S and T, yep, those two. So you're gonna take this triangle, and if you were to stick it in this quadrant right here, pi over 4, what angle would you be from here to here? 3 pi over 4, you got it. Good job. And what would you be if you were in quadrant 3? 5 pi over 4, good, you got it. You got it. Good job. Okay.
Is that it?
No, we have a few more. We have a few more. 34, these are easy. List the transformation, these are super easy. How do you go from here to here?
You move down 2.
2 down. That's easy, right? How about 35?
Reflection.
Reflection over the x-axis. Isn't that negative? How about 41?
Vertical stretch by 3 and up to.
Vertical stretch by 3 and up 2. This is called your amplitude. Your amplitude is 3. How about 42? Vertical stretch by 5, and that's an amplitude of 5 and up 3, right? 43, up 3. Okay, these ones you're gonna sketch these graphs. 44. And you can just do a general sketch, okay? Just do like this, 1, 2, 3, 4. Just give me one period, okay? How's that? Where would you start? Just do this, 1, 2. Where would you start? At -2, good. And you would go up, and then here, here, and here. These are what you did yesterday. Okay, so if I wanted you to sketch another period, it would be here. And by the way, that's 2 pi. How about 45? 45. So we have 1, 2, 3, 4. And we gotta go 1, 2, 3, 4, 5, and 6. So we're gonna start at 1 unit above the x-axis. That's our vertical shift, 1 unit up. And now the sine curve with a stretch of 5. So from here, you're gonna count 5. 1, 2, 3, 4, 5. So it's going up to 6. And then back down. And then how far down am I gonna go? 1, 2, 3, 4, 5. I'm gonna go down here to 4, -4, and back up. You can't do tangent. You could do this cosine one. And I would make my graph, I would change it like 1, 2, 3. I would make that 1. Okay, how would you graph this one? Start where? These are a quarter. You're gonna start here. You're gonna go here, 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 and here. Now, obviously, I had to do that because it's a vertical compression and a reflection over the x-axis. Yes.
I have to like pee, so. I've been holding it.
Next
all
one.
out.
You're on camera.
So.
How would you do this one? I'm gonna do, that's 1, -1. Actually, no, I shouldn't do that because I'm gonna be off the page, because it's, let's do that. Okay, this one, your new x-axis is gonna be at -1. So we're gonna start at the new x-axis right here, and we've gotta count 3 units above. So when you do 3 above, where are you gonna be? That's 1, 2, 3, you're gonna be like right in between here. And then down, whoops, not here. You're gonna be down right here, and then you're gonna go 3 down. So 1, 2, 3 here, and then back on. Okay? Now, can you tell me really quick which graphs are which? For 49,
I already did them.
what are they?
Cosine.
Huh?
Oh, I did the actual.
Which ones are which?
E,
Which one's 51?
E.
That one.
This one?
Yeah, A.
Miss Audie, I'm about to like pee my pants, Megan.
Okay, go ahead.
That's on camera, that's nice.
So which one is 51? Is it A?
It's
Is it
E.
A?
E.
She's wearing her pajamas.
Okay, it's +1. It's shifting 1 unit up and it's upside down.
E.
Which one is
That's
it?
the graph.
E.
You didn't
Isn't
even
it
show
E?
us E.
Here's C.
I
No,
don't think it's E.
because,
So 49's D, 51's E,
Yeah, it's E.
50 is C, 4 to 54 is B. And 52.
Wait, what did you say 51 is?
E.
51 is E, yes, it's E. I thought you said it's not E.
Oh, it is.
It's
No,
E.
you said
This one's E.
49's D.
49, you don't know yet.
Oh,
How about 50? Do you know which one 50 is?
C.
50 is C, yep, because it's a stretch of 2.5, that's C.
18.
What else?
54 is B, I think.
54 is is B, yep, yep.
And then 53 is
53 is not A, because that's a tangent. 52 is A, yep. And the other two are gonna be the tangent graphs. These are what the tangent
Oh,
graphs look
52's
like.
tangent.
Thank you.